Hello, and thanks for attending this quick video info share with some tactical guidance you can use. We're assessing the cost impact of recommended COVID response strategies in hotels. These are smart and tested techniques for keeping costs low for hotel operators during the pandemic. We are not providing guidance for those of you with PTAC systems. This is focused only on VRF or chiller boiler systems. So as we know, the hotel industry has been impacted heavily by COVID, and that everybody is working hard to get hotels open, to reduce the risk of transmission, to consider the recommended safety standards and the impacts on those costs, whilst trying to bring customers back safely. From the guidelines, we've selected the applicable measures for hospitality type of buildings. Some of these are low energy impact and easier to understand. Others are trickier in practice and higher energy impact, but equally important to maintain a safe building environment. So in this study, we're focusing on the measures of shutting off air circulation internally, using outside air, and maintaining the CO2 level in the building. Now, to better answer these questions, we took the approach of whole building simulation. And the model that we used was from the Department of Energy. It's the E+ model, which is the large hotel building with 7 floors and 159 guest rooms, as well as public areas such as a banquet, cafe, dining or lobby, etc. The guidelines that we've looked at are from the United States and Europe, the ASHRAE and the RAVA guidelines. And the goal is to figure out the most applicable and practical measures to take during the pandemic, along with the energy cost impact and some suggestions to keep the building safe with the least possible cost. And so the first tip that we pulled out was that you should keep your CO2 levels under 500 ppm, potentially by increasing outside air supply, because a higher CO2 correlates with a higher risk of transmission. So we've run 2 models with 4 variables. The first model is for low occupancy, and the variables are baseline, shut off return air only, shut off return air and increase minimum outside air by 10%, and the fourth one, shut off return air and increase minimum outside air by 30%. Now this is, like I said, a 32% occupancy rate, which is around half of usual. With a lower people density and a social distant compliant building. So here you can see that these COVID-19 measures have, when shutting off the return air and increasing the outside air, both increase the total bill. So by shutting off return air, the annual bill is only increased by 22%. But when increasing outside air as well, the bill would increase by between 28% and 41% if you went for the 10% or 30% outside air variables here. So quite significant increases in cost. So let's have a look at a future scenario where we're back at normal occupancy with these measures in place. So if you're at normal occupancy, things get expensive very quickly. So, normal people density here in a 65% occupancy rate. If we only shut off the return air, then you're seeing a 1.73 times higher bill. This measure alone shows a big impact on energy consumption, as we can see, which is easy to understand because the buildings were not originally designed to handle COVID situations. So in a typical HVAC system design, there's only a small amount of fresh air and mostly return air that's being circulated back to the rooms, so that we can recycle the remaining cooling and heating energy in the return air. So by shutting off return air, it basically means we cannot utilize and recycle that energy anymore. So it's a large energy loss. And looking at scenario 3 and 4, if we increase outside air, as before, we've simulated an increase of between 10% and 30%. We did not go above 30%, considering a realistic concern of the limitations of a typical supply air system design and the potential issue of increased noise level due to the increased amount of airflow. So these are both areas you need to pay attention to before implementing your strategy. And when we reach the 30% outside air, the supply airflow rate has reached 2,613 CFM for a guest room. The increased energy consumption here is easy to understand. If you imagine more hot or humid outside air coming from a hot summer, or more freezing cold outside air entering the building in a cold winter, the load on the HVAC system to heat or cool that air will go up, and so therefore does the energy cost. So now we've got a better idea of the impact on energy cost. The question is, are they all necessary? And what really is the minimum we should do to keep our buildings and the people in them safe, as well as keeping the operating cost as low as possible? So if you look at return air, it does seem advisable to shut off return air because it mitigates the risk of virus transmission to the fresh air supply. Unless you have in-duct UVGI, which of course you'd need to consult a professional for installation. If, however, you look at increasing outside air, it may not be necessary. So if your building is already compliant with ASHRAE 62.1, then you can typically guarantee under 500 ppm in hotel buildings. As you can see here, these two models, both the low occupancy on the right and the normal occupancy on the left, both project a less than 500 ppm CO2 level when compliant with ASHRAE 62.1. The recommendation that we have is to check the outside airflow rate in your hotel before taking these costly actions. So Verdigris is here to help. We want to answer any questions that you've got. We appreciate and we talk to directors of engineering, chief of engineering, people who are responsible for operating hotels all the time. And we understand that out there right now, people are doing lots of different jobs and they're getting pulled into lots of different situations. And as much as they enjoy the engineering challenge of working with their HVAC system, they don't have a lot of time. And so, if we can help, please reach out. We're here to help with anything related to these questions. And, we just want to help you guys get back up and running profitably as soon as possible. So just a few notes at the back of this. Obviously, all of these projections are subject to building location, floor area, HVAC type, design outdoor airflow, duct system condition, all sorts of different variables there. There's an example here of what the outside airflow rate would be if you're ASHRAE 62.1 compliant. Retro commissioning is recommended for ASHRAE 62.1 fresh air compliance because your duct system degrades over time. And you do need to holistically consider your HVAC capacity before adding outside air. So consider your duct work and your load capacity. But also the noise level will increase if you're introducing a lot of outside air. So the guest rooms may be affected by that additional noise. And really, because this simulation only serves as guidance and has limited scenarios, our key recommendation is to make sure you have a CO2 sensor is the best way to figure out how fresh the air is in your building. Now, we are here to help. We're happy to understand your situation and discuss those things with you. We look at these challenges all the time. So please do reach out to us. Verdigris is here to be your partner through this and beyond. And we hope you found this useful and you have a great day.